Hello guys, today we will be solving a Leetcode problem which is vertical order traversal. The problem number is 987 which is of hard level. The problem statement states that you will be given a tree, a binary tree, and you have to return a vertical order traversal. Now what does that mean? So we have to return the elements in such a fashion that we have to return 4 first and then 2, then 1, 6, 5, 3, 7. Now what does that mean? Generally when we do level order traversal, we return the elements which are at the same level, same horizontal level. That means we are going to return 1 first, then we'll return 2, 3, then we'll return 4, 6, 5, 7. So this is going to be the level order traversal. While it comes to vertical order traversal, we have to return the elements which are in the same vertical line. So just the basic concept changes, where we consider the vertical levels instead of horizontal levels, and also we have to sort them in such a way that the elements which are at the first horizontal levels should be in the first list, and then comes the elements which are at the next horizontal level. For example, while we are returning the elements of the vertical order traversal, the number 1 which is at the top, that means which is at the horizontal level 0, should be pushed first into the list, and then we are supposed to push 6, 5, as 1 is at level 0 according to the horizontal level and 6, 5 is at level 3. And when we have 2 or more elements at the same horizontal level of one vertical level, we are supposed to sort them by their values, not by their positions. Here we are sorting it based on their levels. Once we are done with sorting based on their levels, we are supposed to sort the elements which are at the same level, same horizontal level, based on their values. So this is the tricky part we are supposed to deal with. Now I'll show you the output of this example, then we'll start with the intuition behind it. So at this level we have 4, and at this level we have at -1. I just represented that with numbers so that we can go ahead with the intuition. So we have 2 at this level, and at this level we have 1, 6 and 5. We cannot directly return 1, 6 and 5. First we'll sort it. So 1 comes first in the horizontal level according to horizontal level. Then we get 6 and 5. And when we get 6 and 5, we are not supposed to return it directly. We are supposed to sort it based on their values as they are present at the same horizontal level. This point should be remembered while solving the problem. So the order should be 1, 5 and 6, and then comes 3, and then comes 7. So this is the output we are supposed to return to the function. I think I'm clear. Let's go ahead with the intuition. So what we are supposed to do is we need a few data structures. So we will perform a level order traversal. For that we need a queue data structure which has elements, the address of a node, address of current node. Along with it we will have a vertical level, so that to store the respective vertical level elements in one list. If we have many elements in one vertical level, we are going to store all of them in the same list, and that's how we maintain the order, right? We'll have the current node address, we'll have vertical level along with it, and also we will need horizontal level to actually sort the elements. As I have already said earlier, that we need to sort the elements based on their horizontal levels. So if we consider this one, we will have 1 first and then 6, 5. We cannot return 6, 5 and 1. So for that we need to store the horizontal level, and also to sort this one we also need the horizontal level, and you'll get to know while I explain the code. So what we have to do is, for the level order traversal, and you must be having a prerequisite of level order traversal. I need not explain that here right now. So firstly we will push the first node, which is going to be 1, and its vertical level is 0. I have written it here, 0, and we'll also have the horizontal level which is at 0. This is 0, this is 1, and this is 2. Yeah, right. So we'll push it, and now we'll take another data structure which is map, which is going to store all of the elements at their respective vertical levels. So once we have taken this, in the map we have vertical level as our index, and as the key we have a vector of pair where we store the address of the node and the horizontal level with it, so that we can sort it once we are done filling the elements in the map. So at this vertical level 0, we have element 1, right? So we are going to store the element 1. Along with it, we are going to store the horizontal level. Yeah. So this is going to be the first element. Once we are done with this process, we are going to pop this, and we are going to insert the elements which are left and right to it. So now we are going to insert the elements which are left to the root node. So we will go this side. So we are going to have 2, 2 is going to be the node value, or I am considering node value, but you are supposed to store the node address. 2, the level is -1, the vertical level, the horizontal level is 1, right? So this is 1, this is 0, this is 2, and this is -1. And we'll also store the element which is right to it, and then that's what level order traversal actually means. So it is going to be 3, 1, the vertical level 1 and 1. So once we are done that, we'll have the pointer here, and we'll check, and we won't check, we'll directly insert. What we do is, at -1, we have the element 2 with the horizontal level 1. So this is going to be 2, 1. Yeah. Once we are done with this, we are going to pop this as well, and we are going to insert the elements which are left to the 2 and also right to the 2, so that we get the level in that way. So it is going to be, first we'll do the left element. It is going to be 4, the vertical level is -2, it is at second horizontal level. This is second horizontal level, and this is -2, right? And to its right, the right node of the 2 is 6. So we have 6, -1, which is the vertical level, and it is also in horizontal level 2. Now what we are going to do is, our pointer will be here now, as we've popped the earlier element. So at 1, which is this, we are going to store the address or the value, the horizontal level, which is 1, right? Now we'll pop this, and we'll store the elements which are left and right to it. So to left of the 3, we have 5, which is at the vertical level 1 and horizontal level 2, and we also have 7 to its right, which is 7, which is at the vertical level 2, horizontal level 2. I think you must be familiar with this concept right now. Yeah. Now we'll go to this, and we'll see at -2 in the map, we will store the element 4, 2. 4 is the node value and 2 is the horizontal level, and we'll pop this, and we have no elements to 4, so there is going to be null. We do not insert null here, so we'll leave it as it is, and we'll go to this. Now at -1, we have the element 6, and the horizontal level is going to be 2, right? And we'll pop this, and we'll see if there are any elements to its left or right. As we can see, there are no elements. It is going to return null, and we can leave it. And now 5, 1, 2. So at vertical level 1, the vertical level is 0. Sorry, I'm extremely sorry. This is also be 0. So yeah, so this is going to be it. And now at vertical level 0, we have 5, and the level is 2, and this is also 2. And we'll pop this, and we'll go to the next element, and at vertical level 2, we have 7, and the horizontal level is 2. So this is going to be the final data structure. And now what we'll do is, now we'll have a sorting function which sorts all of these elements. So before that, what we'll do is, we'll try to sort these elements. The function is going to be like, we'll check the horizontal levels, we'll consider this one, we'll check if this value is less than this value, then this value should come first, and that is how customized sorting function will work. So when this value is less than this value, we will have this value first in our vector, and if we have the same horizontal level, we will check these values 6 and 5, and as 5 is less than 6, we will get 5 first and then 6 next. And once we are done sorting in this manner, we will store all of these values into a vector. So at last we'll have the values like 4, 2, 1, 5, 6, 3 and 7. So this is going to be our final answer. Now I'll walk you through the code. The code seems to be a bit complicated, but just don't go by the looks. It seems to be complicated, but the logic is pretty easy. So this is the logic. So initially we have a vector, vectors of vector, where we store the resultant answer. So what we'll do is, we'll check if the root is null. If it is null, we'll return the vector empty. As I've already said in the explanation, we'll need a queue and a map. A queue consists of root node, the node address. This integer represents the vertical level and this integer represents the horizontal level. Here in the map, this integer is the key, which is going to be our index, and this vector consists of two integers, which is the first one is going to be the value, the node value, and the second one is going to be the horizontal level. We are maintaining the horizontal level in our vector so as to sort it according to the horizontal levels. I hope you are getting the point. So as I've already said, we are going to push the first node, which is going to be root node, and its vertical level is 0 and horizontal level is 0. Once we are done pushing that, we will first take that first element, which is the first root element, and store it in the same data structure, and we'll pop it. And this represents item dot first dot second, which is that is this pair dot second. That means this represents the vertical level. So mp of vertical level dot push back. Our map has key value vector, so we are going to push this back. In this in the vector, we are going to have the node value. This is the item dot second, which is this is the item, complete item, and in this we have this is second. I'm taking here the first horizontal level, and then I'm considering the node value. So this is the item second, and this item dot first val, which is item dot first. This is the first, and this is the val, and this first val is going to be the node value. So this way we keep on storing the elements, and once we are done with the first element of the queue, we'll push the left elements. So if we find the left is not null, then we will push the element. In the same fashion, we push the root node, which has the node address and the vertical level, where for the left we are going to decrease it. As I've already said, the first vertical level is 0. When we go to the left, we will decrease the vertical level, which is -1, and again to the left -2. If it is right, we'll add it from 0 plus 1, it is 1, and from 1 to next vertical level it is going to be 2. So this statement makes sure that the vertical level is keep on incremented, this one, and this stores the horizontal level. So initially it is 0. From root node, the elements of left and right are incremented to the next horizontal level, which is the 1, 0 plus 1 and 0 plus 1, and from there it is going to be 2, 3 and so on. So once we are done the level order traversal and storing the values into our map, we are going to sort it. So the element of map, we are going to use this for loop, where we sort the a dot second means the vector dot begin, a dot second, which is vector dot end, comma cmp. So I'll show the customized sorted function. So here the a dot first, that means the first element of the vector, as I've already said, it is the horizontal level. If the horizontal level of the first element is less than second element, then the order is right, and if both of them are same, that means there are more elements in the same level, we are going to sort based on their values. So we'll consider the second, a dot second, which is the node values. Just have explained in the theory part, where 5 less than 6, so we'll get that. If we have 6 and 5 here, we will return false, and that way we can sort the entire vector. So once we are done sorting, we'll simply store all of that in our resultant vector and we are going to return the answer. Now let's check the output. Yeah, it's working. Thank you guys for watching this video.